So next up, we have Jacob Maine with the Clojure REPL and thoughts on unit testing.
Thank you. So can you see my screen?
Yes, I see the words test last.
Perfect. So at my first job as a new programmer, we typically got assigned 6-week-long projects. During the first 4 weeks or so, we'd write the implementation, and along the way, we'd manually test to explore design options and find edge cases. When we ran into bugs, we'd diagnose them by adding print statements or occasionally by running a debugger. And for the last 2 weeks of each project, we'd write tests. I'm not exactly sure in retrospect why we wrote those tests. Maybe they helped prevent regressions, but I think they were mostly to prove to ourselves and our team that we had understood all the requirements of the project. My second job was very different. It was a strict test-first company, meaning we wrote tests before writing any implementation. Up on the walls were posters that said red, green, refactor, meaning write a failing test, then the implementation that makes it pass, refactor to clean up, and then start over. This was a totally different way of testing, and it was really exciting. I felt it was a huge boon to my software. I didn't have to have a grand vision of how everything would work before starting. I could explore the API of the code I was writing as I went, moving things around to where they made the most sense, and I could really quickly iterate. If I didn't know whether something was working or if I couldn't figure out how to make it work, I could always write another test that got me a little bit closer, and then keep rerunning that test until I was making progress again. Ultimately, I was asking the same question I had been asking with those manual tests and print statements. Does this line of code do what I expect it to? Does it work at all? As programmers, I think we don't like to admit how much time we spend in this state. We tell ourselves we know how a function or a class or even a whole system works, but often we don't completely understand how even a single expression works. More often than not, we have to go through a few iterations before we get that first green test. We're leaning on our tests to understand, does it work at all? I want to tell you about one day at this second job. I was sitting next to a senior developer who was working on his own project. He had spent a lot of time around this company and had a deep knowledge of the many ways to test and the benefits of each approach. Suddenly, he pushed his keyboard away from him, stood up in frustration, and said, "I hate unit tests. Why do we even write them?" I was totally shocked. I had a lot of trouble making sense of this outburst. How could someone who had been so immersed in testing be so against unit tests? Unit tests, especially tests that had been written up front, were such an improvement over the manual tests and even the automated tests I had been running before that I couldn't imagine not wanting them. I felt obligated to know why a tool that I was so enamored with would be disparaged by someone who knew so much more about it. And it took several years to understand what I think he was talking about. Along the way, one of the things that helped me understand was learning Clojure, and in particular, learning to use the Clojure REPL. Many people in the Clojure community have tried to talk about how the Clojure REPL is unique, and it's kind of hard to explain because lots of languages have REPLs. Python, Ruby, and Node have REPLs. You can type into the browser console to see how some JavaScript behaves. And for most people, this is how they interact with the REPL. They open it, type a little code, see what it does, and then close it again. They're just trying to see how the language works. Maybe they'll define a function and call it to see whether that works, but that's about it. I don't mean to offend users of other REPLs, but this is a terrible way of using a REPL. Stuart Holloway, a maintainer of Clojure, has said he's appalled when he sees someone type things into the REPL. In Clojure, using a REPL is a live interactive experience, like having a partner who knows all of your code and can explain it back to you. Your editor, which is much better at formatting and navigating code, is also friends with this partner, the REPL. This integration is more like what some programming communities call a notebook. You ask your editor to send all your code to the REPL, where it's evaluated. As you change code or add new code, those changes are also sent to the REPL. You have the entire language as well as your whole code base evaluated there, ready for you to call. And in this environment, you can have a conversation with your code via your REPL. At any moment, you can write a little snippet in your editor, perhaps a function call which transforms some data. You send that to the REPL evaluates it and sends the return value back to your editor. Maybe the return value isn't what you expected, or maybe the function you called isn't even defined yet. You go and write or fix the implementation, send that to the REPL, then reevaluate your snippet. What does it return now? Does it work as I expected? What if I pass in this other piece of data? It's the same process. Did that do what I expected it to? And what's interesting is that over time, the REPL starts to replace some unit tests, at least the part of the test that check, does it work at all? I think, looking back on it, this helps explain what that senior developer was so frustrated about. When you have thousands of unit tests, one for each expression, they can make large design changes much harder. When you decide you want to make a dramatic change to the system, some core algorithm change or step sequencing change, you run into a problem. As you start to make the change, you end up with hundreds of failing tests. Typically, the failing tests are spread across the whole test suite, and it's incredibly difficult to tell which tests are good and which are bad. That is, some are failures that indicate genuine flaws in your new implementation or in how it integrates with the rest of the system. But others are related to code that you intend to delete or are transitory failures that will get fixed as you make progress on the new code. Many of these tests will eventually be deleted or totally rewritten. When you have hundreds of failing tests and can't tell which ones to pay attention to, you might be excused for saying you hate them. And thinking about it, the reason for all these various test failures is that many of your tests were just checking, did this code work? But you no longer care whether your old code works. You want to know whether the new code works, and in turn, whether the system as a whole works. In the stunned days of hundreds of failing tests, you're faced with a choice. Either you can fix each test as you go, perhaps fixing a test many times, even though it's destined for eventual deletion, or you can ignore the test suite for a while and go back to fix it all at the end. In either case, your tests are working against you. They aren't helping you refactor to a better design, and they aren't helping you avoid mistakes as you go. Instead of getting to explore your new design quickly, you spend a bunch of time fixing tests. Your tests are slowing you down. They're discouraging change. That's why I think maybe this style of using the REPL to give you feedback on whether this new line of code works is totally acceptable. It lets you figure out the steps in your algorithm piece by piece, line by line, by trying them out. And eventually you build up to having a whole series of transformations that, when strung together, do what your feature calls for. And here's what I think. At the end, you should write a test for that. Write a test that checks whether the whole pipeline of transformations works. The input to and output from that pipeline defines the core logic of your feature. And those initial and final values are less likely to change, even as the internals of the pipeline change. As your core algorithms change, as you split up and recombine the steps, that higher level test is likely to remain valid and useful. But those little tests you wrote along the way to check, did that line work, will lose their relevancy and won't tell you any more than that larger test does. Now, I'm not at all suggesting you stop writing tests or even advocating replacing all that many of them with snippets you evaluate in the REPL. Maybe your language or editor doesn't even have a really integrated REPL. Instead, I'm mostly suggesting that you take a long look at each unit test after writing it. Is it checking? Does that line of code work? If so, after getting it to pass, consider deleting it. I think that'll leave you with a system that will continue working over the long run and will always be amenable to deep changes. That's where I am with using the REPL and how it's teaching me to relax a little bit about making sure that every line of code has its own test. If you're just getting into Clojure or use Clojure but don't use the REPL, I highly encourage you to spend some time getting it working. Unfortunately, it's not that easy usually, but there are resources out there for getting you started. Spend some time exploring it. You're not going to get really good at it right away, but I think that one of the joys of software is getting good at something. And I think that getting good at using your REPL is a very rewarding process. As you do it, think about what you might want to use your REPL for and what you might want to use unit tests for. Maybe one can fill some of the roles of the other. All right, that's it. Thanks.
Thank you so much, Jacob. Any questions?
I just want to say that was a great conference talk. I would have paid money to listen to that talk.
Thanks. Can't find my screen.
Yeah, I agree that the Clojure REPL experience with the editor is definitely much better than, just copying and pasting code into a REPL and then being able to load your whole project into the REPL without actually, and then interact with it, is actually really powerful. That's really it is kind of unique to Clojure, I think.
Yeah, it
and
took
then
me time to really start doing it regularly, but now it's invaluable.
Yeah, I mean, I do kind of also agree with you on like, I find higher level tests to be significantly more valuable. I've countless times I've gone into code that's testing mocks and the mocks are written wrong, right? The mock, you're mocking some third party thing, or it's like sometimes it makes sense. You're trying to mock like an API for an external system, and then that external system, like it doesn't do what you expect it to do in the failure case, or occasionally it doesn't return data, it just blows up and returns HTML, and you didn't have a test for that, right? And so it doesn't really give you the confidence that you still kind of need to do the integration level testing, and like mocking out components within your own application, like to me seems you're making it, as you said, harder to change those components later, because you just care that the whole flow works. You don't care that this particular implementation of this returns, a different thing in one case. If at a higher level, you've handled that and you want to refactor and make this API more consistent with some other aspect or whatever, and now your tests are constraining you to not break that API, and that kind of gets like, yeah, why? I have found a little bit though that if you are making a change that's structural within your application, and it's well factored in the different services, like dependency injection or whatever, and you're able to like replace implementations and feature flag things. If you inject a feature flag and say, okay, well, all my tests should still pass as long as this feature flag is off, and then you write new tests with a feature flag on, and then everything should still pass, because if you've broken it, and then you can go like, when you turn it all on, everything still passes, then you can go and delete all the tests, and then you're like, maybe I need to write more tests because I just deleted a lot more tests than I expected to delete, which is probably a little bit better than hacking the tests as you go along. But that's just my 2 cents.
That's an interesting approach to making those big changes, is to feature flag off the old way and leave the tests for it until you've totally written the new way. About mocking, I think that a lot of mocking is there to keep your tests fast, or independent, or not so dependent on side effects. And you're absolutely right that a highly mocked test suite might look like it's all green, but when you take the mocks out and run the real system, everything's broken. Definitely seen that happen. I think that a cool thing about Clojure is that as you get more experience with it, you learn how to spread those side effects out. You have like an incoming API request, and then you do a bunch of stuff, and then you put a result in the database. And Clojure encourages you to just use values, data structures for that whole middle transformation step. And you don't need the tests that do the full integration. You can have these isolated or isolated tests that are side effect free that just test that transformation. Maybe you have a couple tests that are that do the integration that involve the first and last step, but usually just one or two sort of makes you confident that you can that whole system works in all cases, and then you can just focus on the logic. And that's not really a REPL thing, but it is definitely part of writing nice tests and in a way that like Clojure makes that better.
Yeah, definitely. Well, I have to drop. I wish I could stay a little longer, but thanks for the talk. That was great.
Yeah, thank you, Kurt.
Thank you, Kurt.
Going back to something you said earlier, what editor would you recommend is a good one for this kind of, to learn this kind of integration of a REPL into an editor?
Well, the classic example is Emacs. But honestly, all of the editors can do this now. A lot of people are using VS Code in the Clojure community, but it's also popular, as far as I can see, for lots of different languages. But really, any editor can probably do this. And in the Clojure world, a lot of the details of running a REPL are actually not in your editor at all. All of that stuff is sort of software that runs outside of your editor, and your editor just plugs into. So that means that many editors provide some sort of REPL for Clojure development. I think the really important thing is to find an editor where you don't have a window that you type into for, or maybe it's there, but I suggest not using it very much. That process of like typing into a window is really slow. What you really want is to have have your file open with your code in it and be able to send chunks of that file over to the REPL. There's something really magical about that piece, and it means that you have like this excellent editor for manipulating what's happening in the REPL. And so if you have that, regardless of which editor you use, I think you're really getting the full benefits of the REPL.
It's kind of hard to understand what this is unless you've experienced it. It's the fact that you can go into your editor and you can either say, just send this whole file over to your running system, or you can highlight certain parts of the file, say, send that over to your running system. And the actual Clojure REPL code can take an incoming function definition, essentially patch the running system and let you do. Then you can type whatever you want, add it, and see what the results are.
Yeah. It is really hard to explain, and lots of people have tried. It's really kind of just something you experience.
I mean, this is compared to something like IRB or IEX. This is a whole level above what it does. I've seen some things with Python with notebooks that are kind of similar.
Yeah, notebooks are sort of a different take on the same idea of how do you sort of mix your editor experience with code evaluation and getting to see and then manipulate return values. And
I mean, see and manipulate return values actually is a very important part, because when you can type an expression get the result back, and then work on that result using, well, how do I find this? So you can just sit there and actually type a function you think is going to find what you need out of that return value and see what it does. And then if you get it right, you already have it in your editor. So you can either paste it into a function that needs to go into, or maybe that is the function you need.
Exactly. And that process of seeing where am I now, and then getting some data back and doing that next step to reach down into that data somewhere to find the next thing you need. Like that is the process of developing a pipeline of transformations that will implement your feature, and you're just naturally directed towards breaking the problem up into those individual steps. And that's sort of how Clojure wants you to write code, and is how the REPL wants you to write code, and gets you to a point where you have these bigger chunks that you can recombine, and more importantly, like test as big pieces.
Okay, that does it. I'm going to learn Emacs.
Well, if you don't like Emacs, there's a paid plugin for IntelliJ that does the same thing. And I haven't done Clojure for a couple of years. VS Code was pretty, it was not a good choice a couple of years ago, but that could have completely changed.
Yeah, the IntelliJ tools are good and popular. People use Vim. There have been Clojure communities that have come and gone with the various other editors. There was a bunch of people that used Atom for a while, and but it seems like VS Code is the popular choice for someone just starting nowadays.
There was, at one point, there was an editor that it had sort of a visual REPL thing, and it would actually display the results next to the expression that computed them. It was really cool, but never really caught on.
Yeah.
Is there, maybe it was mentioned earlier, but is there still a Clojure users group? I know Dan Glasser used to run that.
It still exists. We haven't done anything for quite a long time.
Well, and I know that probably happened before COVID, but COVID, so. Okay, yeah. And I don't know if this group does it. I thought they did. If you guys need IntelliJ, I think they get free licenses. I know the Jug does, the Java users group that we can give away that JetBrains gives out. So if you want to mess with it, you obviously have to pay extra for the plugin John mentioned, but IntelliJ is really nice. I started using it because NetBeans stopped supporting Python, and so I couldn't do Java and Python, and so I went to IntelliJ.
So
we have one IntelliJ license to give out if anyone wants one.
Okay.
at least I was a Cursive user, which is the plugin for IntelliJ. That worked with the community edition.
There are also other tools, so a REPL is not something that has to run in your editor. It can run in a terminal or elsewhere. And there are some other tools in the Clojure ecosystem where the REPL runs in a browser. So you have your editor, and this browser also has all of your code. It's sort of synchronized with your file system, and it's constantly refreshing. And people are really exploring lots of cool ways to enhance that experience. Like with a browser, you can do lots of code exploration, have the browser let you dive into a complex data structure or something. So
I think we need to be clear about one thing: the REPL never runs in the editor. The editor has special code that connects to the REPL process. I'm not sure if they use name pipes or sockets these days, but basically how it works. So it's like you type input into the REPL itself, but the editor is just sending it over like it was typed.
Yeah, that's a more accurate way to describe it.
The advantage of that is that you have captured what you typed. If you just start up a REPL, you can do anything you want with it. Any of these things you want. The problem is the code you type in, you no longer have because it's scrolled off the screen and it's gone.
Yeah, right.
Well, does anyone have any remaining questions for the last 7 minutes? Cool, that was a great discussion. Jacob, thank you for such a wonderful presentation.